Emergency disconnect seal connection. The pipe connecting the emergency disconnect seal to the underground line should be rigid. Electrical metallic tubing, that is, EMD, and polyvinyl chloride, that is, PVC, are acceptable materials for underground installation, but they must be properly joined and tested to ensure a gas-tight seal. Switchet dispenser. The non-rated switch mounted and the bell box should also be rated for use in hazardous areas. Even low-voltage switches can generate sparks that could ignite propane vapors. Lighting. High-intensity discharge, that is, HID, lights are generally safe for use in hazardous areas, provided they are properly installed and maintained. The light in question should be at least 12 feet above the ground or otherwise protected from possible contact with propane vapors. Additional considerations. In addition to the observed deficiencies, other potential hazards that should be evaluated include firstly, underground piping. Ensure that the underground piping is properly marked and buried to the appropriate depth. Secondly, electrical wiring. Inspect all electrical wiring and connections for damage or loose connections. Thirdly, ventilation. The dispensing area should have adequate ventilation to dissipate propane vapors. Fourthly, training. Ensure that employees are properly trained in the safe handling and storage of propane. Based on the observations, it is evident that the propane distributor was not taking proper precautions to minimize the risk of explosions or fires. These deficiencies could have led to serious accidents. It is important to address these hazards through proper maintenance, repairs, and staff training to ensure the safety of the facility. In a hazardous location, electrical equipment must be suitable for the specific hazard. This suitability is determined by various factors, including the class, division, and group of the hazardous location as defined by the National Electrical Code, that is, NEC. The NEC Article 500 contains the general requirements for electrical equipment and wiring in hazardous locations, while Articles 501 through 506 provide specific requirements for different types of hazardous locations. Class I locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division I locations are those in which ignitable concentrations of flammable gases, vapors, or liquids exist under normal operating conditions, or in which ignitable concentrations of such substances may exist frequently because of repair or maintenance operations or because of leakage, or in which breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases, vapors, or liquids and might also cause simultaneous failure of electrical equipment. Division II locations are those in which ignitable concentrations of flammable gases, vapors, or liquids are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or in which ignitable concentrations of flammable gases, vapors, or liquids are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that are adjacent to Class I, Division I locations, and to which ignitable concentrations of flammable gases, vapors, or liquids might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. The specific requirements for electrical equipment and wiring in Class I, Division I and II locations are outlined in NEC Article 501. These requirements include the use of explosion-proof equipment, intrinsically safe systems, and purged and pressurized systems. Class I and II locations are those that are hazardous because of the presence of combustible dust. Division I locations are those in which combustible dust is in the air under normal operating conditions in quantities sufficient to produce explosive or ignitable mixtures, or where mechanical failure or abnormal operation of machinery or equipment might cause such explosive or ignitable mixtures to be produced, and might also provide a source of ignition through simultaneous failure of electrical equipment, operation of protection devices, or from other causes, or in which combustible dust of an electrically conductive nature may be present in dangerous quantities. Division 2 locations are those in which combustible dust is not normally in the air in quantities sufficient to produce explosive or ignitable mixtures, and dust accumulations are normally insufficient to interfere with the normal operation of electrical equipment or other apparatus, but combustible dust may be in suspension in the air as a result of infrequent malfunctioning of handling or processing equipment, or in which dust accumulations may be of sufficient quantity to interfere with the safe dissipation of heat from electrical equipment or other apparatus, or in which locations that are hazardous because of the presence of combustible dust may be communicated. The specific requirements for electrical equipment and wiring in Class Roman II, Division 1 and 2 locations are outlined in NEC Article 502. These requirements include the use of dust ignition-proof equipment and intrinsically safe systems. Class Roman III locations are those that are hazardous because of the presence of easily ignitable fibers or flyings, but in which such fibers or flyings are not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Division 1 locations are those in which easily ignitable fibers or materials producing combustible flyings are handled, manufactured, or used. Division 2 locations are those in which easily ignitable fibers are stored or handled. The specific requirements for electrical equipment and wiring in Class Roman III, Division 1 and 2 locations are outlined in NEC Article 503. These requirements include the use of equipment that is designed to minimize the accumulation of fibers and flyings and to prevent the escape of sparks or hot metal particles. The NEC also requires that all electrical equipment installed in hazardous locations be marked with the class, division, and group for which it is approved. This marking helps to ensure that the equipment is suitable for the specific hazard present in the location. In addition to the requirements for electrical equipment and wiring, the NEC also contains requirements for other safety measures in hazardous locations, such as ventilation, fire protection, and emergency shutdown systems. These measures are designed to help prevent explosions and fires and to protect people and property in the event that an accident does occur. It is important to note that the NEC is a minimum standard, and that local codes and regulations may impose additional requirements. It is always best to consult with a qualified electrical engineer or inspector to ensure that all electrical work in hazardous locations is in compliance with all applicable codes and regulations. Here's a more detailed breakdown of some of the specific issues raised and how they relate to safety regulations and best practices in propane distribution facilities. Emergency disconnect seal connection. The purpose of an emergency disconnect is to allow for the rapid shutdown of electrical power to equipment in the event of a leak or other emergency. This is critical for preventing ignition sources in a potentially explosive atmosphere. The connection from the emergency disconnect to the underground line must be gas tight to prevent propane from entering the conduit system. Using a combination of electrical metallic tubing, that is, EMT, and polyvinyl chloride, that is, PVC, without proper sealing can create a pathway for propane to migrate. The NEC typically requires rigid metal conduit or Schedule 80 polyvinyl chloride, that is, PVC, for underground installations in hazardous locations. All conduit joints and fittings must be properly sealed with a suitable sealant to prevent gas leakage. The transition from above ground to underground conduit should be done in a way that maintains the integrity of the system. This often involves using a sealing fitting specifically designed for this purpose. It's also worth noting that the type of conduit and sealing methods should be appropriate for the specific hazardous location classification. Switch at dispenser. In a propane dispensing area, any electrical equipment, including switches, must be rated for use in hazardous locations. This means that the equipment is designed to prevent sparks or other ignition sources from coming into contact with propane vapors. A standard push-button switch mounted on a bell box is unlikely to be rated for hazardous locations. Even low-voltage circuits can generate enough energy to ignite propane vapors. The switch should be replaced with a switch that is specifically listed for use in Class I, Division 1 or 2 hazardous locations depending on the specific classification of the area. The enclosure for the switch should also be rated for hazardous locations and properly sealed to prevent the ingress of propane vapors. Lighting. Lighting in a propane dispensing area also needs to be rated for hazardous locations. If the high-intensity discharge, that is HID, light is located less than 12 feet above the ground, it should be a listed hazardous location fixture. The reason for the 12-foot height requirement is to minimize the risk of the light fixture coming into contact with propane vapors, which tend to accumulate near the ground. The seal located immediately behind the light fixture is likely intended to prevent the migration of propane vapors into the conduit system. It's important to ensure that the seal is properly installed and maintained. Additional considerations: underground piping. Underground propane piping should be buried at a sufficient depth to protect it from damage. The depth requirements vary depending on local codes and regulations, but typically range from 18 to 36 inches. The piping should also be clearly marked to prevent accidental damage during excavation. This can be done by using tracer wire or marking tape buried above the piping. Electrical wiring. All electrical wiring in the propane dispensing area should be inspected for damage or loose connections. Any damaged wiring should be repaired or replaced immediately. Loose connections can create a fire hazard. The wiring should also be properly sized for the load it is carrying. Ventilation. Proper ventilation is essential for dissipating propane vapors and preventing the accumulation of explosive mixtures. The dispensing area should be designed to allow for natural ventilation. If natural ventilation is not sufficient, mechanical ventilation may be required. The ventilation system should be designed to exhaust propane vapors away from ignition sources. Training. Employees who work in propane distribution facilities should be properly trained in the safe handling and storage of propane. This training should cover topics such as the properties of propane, the hazards associated with propane, emergency procedures, and the proper use of safety equipment. Regular refresher training should be provided to ensure that employees remain knowledgeable and competent. Overall safety assessment. Based on the observations, it appears that the propane distribution facility has several safety deficiencies that need to be addressed. These deficiencies could increase the risk of explosions or fires. It is important to conduct a thorough safety assessment of the facility to identify all potential hazards. Once the hazards have been identified, appropriate measures should be taken to mitigate them. This may involve repairing or replacing equipment, improving ventilation, providing additional training, and implementing stricter safety procedures. Regular inspections should be conducted to ensure that the safety measures are being properly maintained. By taking these steps, the propane distribution facility can significantly reduce the risk of accidents and protect the safety of its employees and the public. Here are some specific National Electrical Code, that is, NEC, references that are relevant to this discussion. Article 500 covers hazardous locations Class I, Roman II, and Roman III, Divisions 1 and 2. Article 501 covers Class I locations, which are locations where flammable gases or vapors are present. Article 502 covers Class Roman II locations, which are locations where combustible dust is present. Article 503 covers Class Roman III locations, which are locations where easily ignitable fibers or flames are present. Article 514 covers gasoline dispensing and service stations. While this article specifically addresses gasoline dispensing, many of the principles and requirements are also applicable to propane dispensing facilities. Article 515 covers bulk storage plants. This article provides requirements for the storage of flammable and combustible liquids, including propane. In addition to the NEC, there may be other applicable codes and standards, such as those promulgated by the National Fire Protection Association, that is, NFPA, and the Occupational Safety and Health Administration, that is, OSHA. It is important to consult with a qualified electrical engineer or inspector to ensure that all electrical work in propane distribution facilities is in compliance with all applicable codes and regulations. Here is an example of how to determine the appropriate hazardous location classification for a propane dispensing area. The first step is to determine whether the area is a Class I, Class Roman II, or Class Roman III location. Since propane is a flammable gas, the area would be classified as a Class I location. The next step is to determine whether the area is a Division I or Division II location. A Division I location is one in which flammable gases or vapors are present under normal operating conditions. A Division 2 location is one in which flammable gases or vapors are present only under abnormal conditions. In a propane dispensing area, flammable gases or vapors are likely to be present under normal operating conditions, so the area would be classified as a Division 1 location. Once the hazardous location classification has been determined, the appropriate electrical equipment can be selected. Electrical equipment that is approved for use in Class I, Division 1 locations is designed to prevent sparks or other ignition sources from coming into contact with flammable gases or vapors. This equipment is typically explosion-proof or intrinsically safe. In addition to selecting the appropriate electrical equipment, it is also important to ensure that the equipment is properly installed and maintained. This includes using the correct wiring methods, sealing conduit joints, and regularly inspecting the equipment for damage. By following these steps, it is possible to create a safe electrical system in a propane dispensing area. The information provided is intended for general guidance only and should not be considered a substitute for professional engineering advice. It is essential to consult with a qualified electrical engineer or inspector to ensure that all electrical work in hazardous locations is in compliance with all applicable codes and regulations. The observations made at the propane distribution facility raise serious safety concerns. The combination of non-rated equipment, potential gas leaks, and inadequate safety measures could lead to a catastrophic event. It is imperative that the facility owner takes immediate action to address these deficiencies and ensure the safety of the employees and the surrounding community. This includes conducting a thorough safety audit, repairing or replacing non-compliant equipment, implementing a comprehensive safety plan, and providing adequate training to all employees. Failure to do so could result in serious injuries, property damage, or even loss of life. Remember that safety is not just a matter of compliance with regulations, but also a matter of ethical responsibility. As a propane distributor, the facility owner has a duty to protect the safety of the public and the environment. This requires a commitment to safety excellence and a willingness to invest in the necessary resources to achieve it. The following are some additional considerations for propane distribution facilities. Site security. Propane distribution facilities should have adequate security measures in place to prevent unauthorized access and vandalism. This may include fencing, lighting, and surveillance cameras. Emergency response plan. Propane distribution facilities should have a comprehensive emergency response plan in place to address potential incidents such as leaks, fires, and explosions. The plan should include procedures for notifying emergency responders, evacuating personnel, and containing the incident. Public awareness. Propane distribution facilities should conduct public awareness campaigns to educate the community about the safe use of propane and the potential hazards associated with it. This may include distributing educational materials, hosting community events, and participating in local emergency planning committees. Regulatory compliance. Propane distribution facilities should comply with all applicable federal, state, and local regulations. This includes obtaining the necessary permits, conducting regular inspections, and maintaining accurate records. Continuous improvement. Propane distribution facilities should continuously strive to improve their safety performance. This may include implementing new technologies, adopting best practices, and conducting regular safety audits. By implementing these measures, propane distribution facilities can significantly reduce the risk of accidents and protect the safety of their employees, the public, and the environment. Regarding the specific issues identified, the emergency disconnect is a critical safety device. The use of inappropriate conduit and sealing methods compromises its effectiveness. Propane vapors could migrate into the conduit system, creating an explosion hazard. The non-rated switch at the dispenser poses a similar risk. Sparks from the switch could ignite propane vapors, leading to fire or explosion. The lighting fixture below 12 feet also presents a hazard. If the fixture is not rated for hazardous locations, it could overheat or generate sparks, igniting propane vapors. The underground piping must be properly marked and buried to prevent accidental damage. Damage to the piping could release propane, creating a dangerous situation. The electrical wiring must be in good condition to prevent electrical faults. Electrical faults could ignite propane vapors. Adequate ventilation is essential to prevent the accumulation of propane vapors. Without proper ventilation, propane vapors could reach explosive concentrations. Employee training is crucial for ensuring that employees understand the hazards associated with propane and how to handle it safely. Untrained employees are more likely to make mistakes that could lead to accidents. In conclusion, the propane distribution facility has several safety deficiencies that need to be addressed. These deficiencies could increase the risk of explosions or fires. It is important to conduct a thorough safety assessment of the facility to identify all potential hazards and take appropriate measures to mitigate them.